Last week we already learned about a tactical decision that includes aggregate planning and master schedules. So here this week I will introduce you some strategy so that you can match the capacity, adjust the capacity to match with the demand, or adjust the demand to match with our capacity. So first one is the level production. So what is level production? It means you don't care how much, how fluctuated the demand is. You just take the average demand and produce the products in the same level over the time. So here is the production line, and here is the demand curve. So here, let me give you an example. I have 4 periods of time, that is spring, summer, fall, and winter. And the sales forecast for each period is in this column. So how we can determine how many products should we produce? So we take the average of the sales forecast, and we have is 100,000 pounds. So we take 80,000 plus 50,000 plus 120,000 plus 150,000 divided by 4. We have 100 pounds. So we decide to produce every period of time we produce 100,000 pounds. And when we produce at this level, we will determine the inventory. So for example, in the first period, that is spring, the sales forecast, it means the demand is 80,000. Is 80,000. However, we produce 100,000, so it means we have extra 20,000 products. So we put it in inventory. Okay. And in the second period, in summer, the demand is 50,000. But we also produce 100,000. So what we have left is 20,000 plus 100,000 and minus 50,000. So we have 70,000 in inventory. So the same, you can calculate the inventory in fall period and in winter. And we will calculate the total production, total products that we produce, that is equal to 400,000. We take the sum of this column, and also the total inventory. We can calculate for the whole time is the sum of 4 inventory in 4 periods. So you have is 140,000. And you can calculate the cost, the total cost, when we use the level production strategy. We have the production cost and inventory cost. So production cost will equal to 400,000, and we have the production cost for per unit is $2. That I give you here, the production cost is $2 per unit, and inventory cost is 0.5. So we have 400,000 multiplied by 2 plus 140,000 multiplied by 0.5. So we have the total cost when we use the level production strategy is 870,000. Okay, we also can use Excel to calculate this problem. Maybe when the data is a lot, we cannot calculate by hand, so we prefer using Excel. So here we also have the column for the forecast demand and the column for production. And production here we calculate by take the average of the total demand. And then how you can calculate the inventory? The inventory will equal to the initial inventory plus the production minus the demand. Okay, so for example here we have the initial inventory is 20,000, that is F11, plus the production in the second period, that is E12, and minus the demand in the second period. Okay, so we will have the formula for this for this one, for this cell. So the same in the fall period, we will have the inventory will equal to the initial. It means the inventory in the second period plus the demand, the production quantity in the third period minus the demand in the third period. Okay, so on and so forth. You can calculate the total demand is 400,000, the total production quantity is 400,000, and the inventory is 140,000. So we in level production, we always try to match the production with the demand so that we can minimize the cost. So the total cost will be equal to E15. Okay, E15 is the total production quantity multiplied by the production cost, that is E5, plus the inventory cost, that is F15, the total inventory quantity multiplied by the inventory cost, that is E6. So we have this the total cost, this cell. So the formula for this cell will be equal to E15 multiplied by E5 plus F15 multiplied by E6. So we have this cell, and that is for that's it for the level production. And we have the second strategy, that is chase demand. So what is chase demand? We also have the line for demand, same as the previous figure. However, for production, they will produce following the demand. So earlier the demand changed via different period, summer, winter, and fall. However, they will keep the level of production is the same, that is 100,000. But here, if the demand is 80,000, they will produce 80,000. If the demand is 100,000, they will produce 100,000. So chase demand is they will produce the same amount, same quantity as demand. And also go back with the same example. We have the sale forecast is this column, but here in test of take the average, we just produce the same quantity as the demand. So for example, in spring, the sale forecast is 80,000, so they will produce 80,000. For summer, the sale forecast is 50,000, so they will just produce 50,000. So here we can calculate the workers needed to produce 80,000 products, and here we can see that one worker will make 1,000 products, and the initial workforce, it means we already have 100 workers. So here we can calculate, because one worker can produce 1,000 products and we need to produce 80,000 products, it means we will need 80 workers. So 80,000 divided by 1,000, so we need 80 workers. However, the initial workers we are having now is 100, but we only need 80, so it means we will fire 20 because we have 100 workers and but we only need 80, so it means we need to fire 20 and we don't hire anyone. And the same in the second period, we have this forecast demand is 50,000, so we also produce 50,000. And to produce 50,000 products we need 50 workers, and now we are having 80 workers, but in the second period we only need 50, so it means we will fire 30 workers and we don't need to hire anyone. Okay, and also the third period we produce 120,000 products is the same as the sale forecast. It means we need our 120 workers. However, we only have 50 workers now, so it means we need to hire 70 workers more and we don't need to fire anyone. Okay, so on and so forth. You can calculate for the whole 4 periods. So we can calculate the total workers we need to hire is 100 workers, and we need to uh, fire 50 workers. And here we will have three main costs. Production cost, you also calculate the total production quantity here, and the total workers you need to hire and the total workers you need to fire. Here we don't have inventory cost because we produce the same quantity as the sale forecast, so we don't have inventory. So we can calculate the total cost when we use the chase demand strategy, that is equal to the production cost, uh, hiring workers cost, and firing worker cost. So we have the total production quantity is 400,000 and the the production cost per unit is $2 here. And firing cost is $500. Hiring cost is $100. So we can calculate the hiring cost is equal to 100 multiplied by $100, because to hire one person we have to pay $100. And here is the firing cost. To fire a person we have to pay for the penalty cost, that is $500, and we need to fire 50 workers, so we have the total cost for firing people is 50 multiplied by 500. So the total cost we have to pay when we use the chase demand strategy is 835,000. So we compare, if we use the level production strategy, we have to pay 870,000. However, when we use the chase demand strategy, we only need to pay $835,000. So in this case, the company should use the chase demand strategy. Okay, so depends on different situation. The company will decide if they should use the chase demand strategy or the level production strategy. So the same for the level production strategy. For chase demand, you also can use Excel and input their formula so that they can calculate for you in case uh, in case that you have a lot of data and you cannot calculate by hands. So Excel can help this situation. So here the production, like for example D11 will equal to C11. The production quantity is always equal to the input demand. Okay, and the number worker needed is equal to the production quantity divided by uh, the quantity one worker can produce. So here E11 will equal to D11 divided by C6. So it's the same for E12 to E15. So E12 will equal to D12 divided by C6. So you just need to input the formula for E11 and you fix C6. Then after that you just copy to the rest of the cell in this column. How about the workers hire? How many workers we need to hire? So we have to compare if the number of workers we need is smaller than the worker we have now. So we have to what we need and what we have. So what we need is smaller than what we have to fire someone and we don't hire anyone. However, if what we need is more larger than what we have to hire someone and fire no one. Okay, so I will input the formula if, the if function for this cell. So if the number worker I need is smaller than the number of worker I have, it means if E11 is smaller than C5 because C5 is the initial beginning workforce that we have. So if E11 is smaller than C5, it will equal to, if it's true, it's equal to 0. If not, it will equal to E11 minus C5. Okay. For the second column, we also do the same thing. If E12 is smaller than E11, then comma, then 0, then comma. If not, it will equal to E12 minus E11. Okay, so just open the Excel and practice as what I'm guiding you here. So for this cell, the formula will be if E12 minus, okay, if E12 is less than 11, comma, 0, comma, E12 minus E11. E12 minus E11. Okay. For the fire column, it will be converse way of the hire. Because when we hire someone, we don't need to fire someone. When we fire someone, we don't need to hire anyone. So if what we need is smaller than what we have, we will need to fire someone, right? So if it's true, it will be equal to the number we fire will equal to the number of workers we have minus the number of workers we need. So here for G11, we will have if E11 less than C5, comma, E11 minus C5, comma, 0. So it's converse way of this one. E11 minus C5 will first and 0 will be after. Okay. So for example, for G12, how can we input the formula for this cell? So we will input if E12 less than E11, comma, E12 if E12 smaller than E11, comma, E11 minus E12, comma, 0. Okay, so it's converse way of the word is higher. Okay, so please open your Excel and practice by yourself. And if you have any questions, feel free to ask me. I will open the Zoom meeting every Thursday, period 4, 5, 6. So please join the Zoom meeting to ask the question. So we just go through the level, production, and the chase demand strategy. So let me repeat again, depends on different situation and different strategy of your company. You will decide to choose if you should follow the level production strategy or the chase demand strategy. And here we have another strategy, because both level production and chase demand strategy have their own advantage and disadvantage. That's why they create another strategy that is mixed strategy. And this strategy is the combination between level production and chase demand strategies. Okay, so I will give you this example that let's say this company, the quantum corporations, the toy company, they have they forecast the demand for 12 months from January to December. So here we have the data for the demands of this company from January to December. And one worker can produce average 100 cases of toys each month. And the overtime, they can work overtime, but it just limited to 300 cases, and the subcontracting is unlimited. So what is subcontracting? It means when you don't have enough products to sell to your customer, and even your workers work overtime, you also don't have enough products to sell to the customer. You can sign another contract with the third party, and you ask them to help you produce the products to sell. So it's called subcontracting. And the initial inventory is 0. Okay, the wage rate is $10 per case for the regular production. So it means you have to pay $10 for the worker per case for the regular production, and if they do overtime you have to pay $15. And if you use subcontracting, you have to pay $25. And we assume that we always have need to satisfy the customer demand. No stock outs are allowed. We have inventory cost or holding cost is $1 per case and per month. And the cost to increase the workforce is $1,000 per worker. This is also means the uh, hiring cost. To increase the workforce, it means you have to hire someone, right? So to hire a person, you have to pay $1,000. And to fire someone, decrease the workforce, it means you have to fire someone, and it costs $500 per workers. And first, you have to make the planning, production, and you check if which plan is, which strategy is the best for this case. So the first strategy that you use the level production strategy. The second one, produce to meet the demand each month. It means you use the chase demand strategy. And the last one, you solve the problem with linear programming with using the Excel solver. So here, please calculate the question A and question B by yourself, uh, because we just go through how to calculate it earlier. And let me check. Okay, so please do the question A and question B, then submit it to me in the assignment. I will open an assignment folder for this homework, for this question. So please do this one and submit it to me uh, in the assignment folder. And please do it in Excel. Okay, I will inform you the deadline later, but maybe I give you until tomorrow because it's quite easy. So until tomorrow, the deadline is tomorrow. I will upload it later in the assignment folder. Now I will teach you how to solve this problem with linear programming using the Excel solver. So we have two ways. We have several ways to solve the linear programming. First, we can use Excel solver, or we can use coding like Cplex or Lingo. But here, uh, due to the limited time, I will just teach you how to use Excel solver to solve LP problem. But if you are interested in coding, how to use Cplex, just feel free to uh, do some research about it. And if you have any questions, feel free to ask me. I can teach you how to use Cplex to solve this problem. So to use the solver in Excel to solve the linear programming, at first you have to determine what are your inputs, what are parameters, what is your decision variable, and you have to determine the objective function. And our objective here is minimize the total cost. Uh, so objective function, decision variable here is we want to find the production planning for regular production. And we also want to know should we do overtime or subcontracting. And next we have to determine the constraint. So here we have four constraints. The first one is the demand constraint. The second one is production constraint. And the third one is the workforce constraint. And finally is the overtime constraint. So here we the green one is the parameter, the inputs. It means it's the given information, and the blue colors here is the decision variables, and the yellow here is the constraint. So first I want to input some information for OT. So if because we can see the cost for overtime is higher for the cost of higher than the cost of regular production, and the subcontracting is uh, cost more than the overtime. So we will put priority that if we do regular production and it's not enough product to sell to the customer, we will do overtime. And if we do regular production and overtime and it's still not enough, we will decide to do subcontracting. So the priority will be regular production, then after that is overtime, and after that is subcontracting. So we will have this column. The overtime column is if uh, the regular production minus the demand is larger or equal than 0, we have to do overtime. Uh, okay, so if if the demand is larger or equal to the regular production, we have to do overtime because we don't have enough product to satisfy the demand, right? And the total quantity we need to overtime is the demand minus the regular production. And here we can see that the regular production is C9, and the demand in January is B9. Okay, if not, it will be we don't need to do overtime, so it will be equal to 0. That is for the first month for January. How about the second month? So second month we need to consider inventory in the first period, because early in the first period we know that the initial inventory is equal to 0, right? So we don't need to consider the initial inventory. But however, in the second period we have to consider it. So if the total regular production and the inventory from last period is not enough to satisfy the demand, we have to do overtime, and the overtime amount is equal to the demand minus the regular production minus the inventory. If not, we don't need to do overtime. So that's why we have the if function like this for the overtime in February. So the same, we just copy it to other cell in this column, so we can find the rest of the value of overtime. So the same for subcontracting, but we just for production quantity we consider both regular quantity, regular production and overtime. Okay, so here we also see if the total quantity they produce from regular production and overtime is not enough to satisfy the demand, they will have to subcontracting. If not, they do not need to. And here in this case in January, the initial inventory is equal to 0, so we don't need to consider the initial inventory. Okay, and in the second one, in the February, we will consider the inventory in the first period in January as well. So we will calculate the total production quantity from regular production and overtime, and also the inventory from January. And if still not enough to satisfy the demand in February, we need to do subcontracting. If not, we don't need to. So it's equal to 0. This is how we use the if function to calculate the value of subcontracting. Okay. So the same you can copy it to other cell in this column to calculate the subcontracting from March to December. How about inventory? So inventory, in the first, in January, the inventory will equal to, uh, you can use maximum between the total production plus overtime, regular overtime plus the subcontract. And also subcontract, and we compare with minus the demand. So it means if we are, it should be also the initial inventory, but it's 0, so you can consider it or not. It's fine. So we will consider two values. The first one is the total production quantity plus the initial inventory, and the second value is the demand. So if the total production uh, quantity plus the initial inventory is larger than demand, we will have inventory. If not, the inventory will equal to 0, right? So we have the function for F9. The inventory in January is like this. The maximum of 0 and C9 is regular production plus D9 is the overtime quantity and subcontracting quantity is E9. And plus the C5 is the initial inventory minus the demand in January. Okay. And we also have another ways to calculate that we can use the if function. So here, but also the same logic that you will compare the value of total production quantity plus the inventory in the last period. So here we can see if uh, the total production quantity plus the inventory in January is larger or equal to the demand in February. If it's larger, we will have inventory, right? And the inventory is equal to the total production quantity plus the inventory and minus the demand. And if not, it will be equal to 0. So you have two ways to represent the inventory, either the max or the if function. Both are okay, so depends on you. You think which one is easier for you, so you just choose it for yourself. Okay, so the next column is the number of workers. The number of workers will equal to the regular, it's based on the regular production, so it will be equal to the regular production divided by the total unit that one worker can work. So here we have the number of workers they need in January is equal to the regular production, that is C9 divided by C4 is the units per workers. And the same you can calculate the other cells in this column. And next column is the number of the people you need to hire So we compare two values, what we have and what we need. So what we have here is the beginning workers, that is 10. And what we need here is G9 for January. So if what we need is G9 is larger or equal to the beginning workers, that is C3, we need to hire someone, right? Because what we need is larger than what we have, so we need to uh, hire someone, and the number of people we need to hire is equal to what we need minus what we have. If not, we don't need to hire anyone, so it will equal to 0. Okay, so the same you can calculate our other cell of this column. Just need to copy it. For the February, the number of worker we need to hire, you will compare also what you need. What you need is G10, and what we have now is G9. It's not C3 anymore. Okay, so you compare between G10 and G9. How about what we fire? How many people we fire? It will opposite from what we hire. If we hire someone, we don't need to fire anyone. But if we fire someone, we don't need to hire anyone. Okay? So also the same, we compare what we have and what we need. So if what we need is less than or equal to what we have, we will need to fire someone. Okay, so if we need 5 people but we have 10 people, so we need to fire 5 people, right? So here we compare what we have is C3 and what we need is G9. And if what G9 is less than or equal to C3, they need to fire how many people? That is what we have minus what we need, right? And if not, it's equal to 0. So here you also can use the max function. You can just construct by yourself. How about in February? So February also the same, you compare between what you have and what you need. So what you need are for February is G10 and what you have is G9. Okay, so please look at here and try to construct the Excel file by yourself. Okay, so we just finished those columns, and we go to the next column. The first one is, do you still remember the requirement that no stock outs are allowed? So it means we need to have enough, we need to satisfy all the demand. So it means the total products we have has to be larger or equal to the demand, because no stock out is allowed. So I create a new column that is the current products or cases that I have, and it will be equal to total production quantity plus the initial inventory. Okay, and for February is also the total quantity they produce in February plus the inventory in January. So I have the current cases in each month. So this value have to be larger or equal to this value because no stock out is allowed. That is the first constraint. The second constraint is here overtime is limited to 300 cases. So it means the total number of overtime has to be less than or equal to 300. So here we see overtime here is 12,000. is larger than 300, so this solution is not good, right? But later we still have this column, and solver will help us solve it again. And the next column is the production constraint. So the total production has to be less than or equal to the constraint, right? And also the workforce, the total of workers we have here has to be less than the workforce constraint. And next we calculate what is our objective function. Our objective function or our objective is minimize the total cost, right? So we have to calculate the total cost. And the total cost here we have first the regular production cost, overtime cost, subcontracting cost, inventory cost, hiring people cost, and firing cost. So here we will calculate the cost, the total cost in each month. That is equal to the first one is the regular production cost is equal to C9 is the quantity produced by regular production multiplied by the cost is $10 is E3. And the second one is here that you have to calculate the overtime cost. That is the total quantity we use overtime to produce multiplied by the overtime cost per unit. And the third one is the subcontracting cost. So here E9 is the total quantity that they produce by subcontracting multiplied by the subcontracting cost per unit. And the next one is inventory cost. So inventory cost is equal to the total inventory quantity multiplied by the inventory holding cost per unit and per month. And the next one is the hiring cost. So hiring cost, we also have the number of people we hire multiplied by the hiring cost per person. And the last one is the firing cost. So firing cost is equal also the total number of people that we fire and multiply with the firing cost per person. So we can calculate the total cost in January, and the same we can calculate for our other 11 months. And remember to fix those parameters like the cost for regular production for overtime, blah blah. So fix it. So you just need to copy that formula for the rest of cell. Okay, and the last step that we calculate is the total cost. So the total cost will be equal to the cost of 12 months. Okay, so I already finished inputting the formula for those columns and rows. So now I go to data, then we have solver here. If you cannot find solver here, if you haven't ever used solver before, maybe it will not appear here. So please go to file, then go to options and add-ins. Then you go here and you click in solver add-in and then OK. So after that, go to data, then go to solver. It will show you. So the first one I want to input, maybe let me reset everything. Okay, so your objective is minimize the total cost, right? So you choose minimize min. And where is your total cost is this value. Then okay, you finish your objective function. So decision variable is you want to change value of which column. So we choose the column of regular production because the overtime, subcontracting, inventory workers, and hire fire will depend on this. They are also decision variable, but calculated decision variable because it depends on the regular production. So we only choose the value of regular production from C9 to C20. Okay, so we finish our objective, function, and also decision variable. And now we add the constraint. So the first constraint, that is, I want my value here, the decision variable, is integer. So it means it's larger or equal than euro. So the first one I have. The second one, that is the overtime has to be less than 300, right? So the overtime, the sum of overtime is here. The 22 has to less than or equal to C23. That is the second constraint. The third constraint, do you still remember? That is no stock out is allowed. So the total of current products have to be larger or equal to the demand. Okay. And the next one is production constraint. So the regular production has to be less than or equal to the production constraint. Okay. And the last one is a total of workers has to be less than or equal to the workforce constraint. So finish here, workforce constraint. Here is the total of workers. Here has to be less than or equal to the workforce constraint. Okay, then you choose. We already finished objective, finished decision variable, and input all the constraints. Then now please choose the simplex LP. LP is linear programming. And after that, solve. Then they will give you the optimal solution here. Of the blue area is the decision variable. So we can see if we use mix strategy, the total cost we will spend is 142,500. With the regular production, quantity is here. So you can see here it's not level production is also not totally chase demand strategy, right? So this is the combination uh, between the level production strategy and the chase demand strategy. Okay, so here we can see when we use the level production strategy, the total cost we have to pay is 146,000. And when we use the chase demand strategy, the total cost we have to pay is 149,000. And when we use the mix strategy, the total cost we have to pay is 142,500. So we see if we use the mixed strategies in this case, we is the best option for us because uh, we only need to pay less cost. And okay, so here I summarize for you how to use the survey in Excel. So first, you have to input the survey like I told you earlier. Then after that, you go to data, then analysis and survey. And you have to, or the step one, you have to set up decision variables. What is your decision variable? Okay, and then you set up the constraint table. And what is your objective function? And you have to create the cell for objective. So there are three main things, that is decision variable, objective function, and constraints. And then you call solver and you input the parameters. They will solve the problem for you. And here is another example you can practice by yourself. uh, Here they have the input as well. And as I mentioned earlier, you can use solver in Excel for the case that just small data set. But for a larger data set, you need to use maybe Cplex or Lingo. Then here is how you know put notation and objective function and constraint. Then based on this one, you can write the code for your example. But this one is quite complicated, so I don't require you guys to know. But if you are interested, please try yourself. And if you have any questions, feel free to ask me. Okay, so in the next one, we will learn about the short-term schedules. So short-term schedules is for daily plan. We make plan for daily demand. For master schedule is for weekly. Okay, and I will talk about this in the next video.